Our next lesson is lesson 16.3, picking a player, calculating and interpreting the mean and absolute deviation. In this lesson, we will calculate the deviations of each data value from the mean of a data set, calculate the absolute deviations of each data value from the mean of a data set, and calculate and interpret the mean absolute deviation for a data set. So key terms, we have measures of variation or variability, deviation, absolute deviation, and mean absolute deviation. So lots of deviation. I know those are new terms for all of you, so that'll be something that we'll really need to focus on in today's lesson. I know this intro, can't skip it because I know a lot of this will interest a lot of you. Fantasy sports have become very popular in the last 25 years. If you don't know, fantasy sports allow participants to take the role of a manager and coach by drafting players, training players, and determining who should start in upcoming games. Weekly and even daily, serious participants scour over player statistics to determine which player might score the most points for their team. I have some friends that really get into this and spend way too much time on fantasy sports. I'm guessing there are a few of you that might do the same. These statistics are based on what each player can do in a real-life game. So why do you think there's an appeal for common people to want to be a fantasy coach and manager? Do you think fantasy sports leagues are popular in other countries too? I'm not sure about that. But one of the things I think that appeals to people is the ability to take those star players and feel like you really connect to them. Aaron Rodgers is on my fantasy team. Jordy Nelson's on my fantasy team, right? So that gives you an opportunity to cheer even louder for them. So we'll be dealing with some statistics like that today. Let's get right into it then and have a great learning opportunity. Now, real-life coaches have the same type of decisions to make, and a lot of them base it off of statistics. We examined previously the points scored by 3 players on the Olive Street Middle School girls basketball team. It says, suppose the team won the game and will advance to the district championship. Coach Harris needs to decide whether Tamika and Lynn will be starters for the game. In the past 6 games, Tamika scored 11, 11, 6, 26, 6, and 12 points. The past 6 games, Lynn scored 15, 12, 13, 10, 9, and 13 points. It says the dot plots for each player's scoring over the past 6 games are shown. So we have the number of points scored by Tamika. It says the mean is 12. And then for Lynn, the mean is also 12. So it says, based on the dot plots, which player do you think Coach Harris should choose? Remember to look at the clues here. It says, what does it mean for both players to have the same mean? Does it matter who Coach Harris puts in the game? So answer that question right now. When you're done, unpause the video. Like the answer key here says, answers might vary for this problem. Some of you might have said that Coach Harris should choose Lynn because her scores are more consistent. She's steadily around 10 points a game. High at 15, low at 9. Whereas Tamika, she has a whopping 26 points in one game, but her low is all the way down to 6. So she's a little less consistent. So you kind of have to decide as a coach, do you want the more consistent player or the player who can potentially score 26 points? That's one of the things you have to factor in as you're making important decisions like that. So it says, when analyzing a data set, measures of center give you an idea of where data is centered, or what a typical data value might be. There's another measure that can help you analyze data, and here comes that first vocabulary term. Measures of variation or variability describe the spread of the data values. Just as there are several measures of central tendency, there are also several measures of variation. So go ahead and mark your text right now for measures of variation or variability. So measures of variation or variability describe the spread of data values. The deviation of a data value indicates how far that data value is from the mean. Underline that right away. It says to calculate the deviation, subtract the mean from the data value. Okay, so the deviation is equal to the data value minus the mean. It says to calculate the deviations for points scored for each player using the equation. Record your results in the tables. Tamika's deviation is completed for you. So the equation that they're referring to is the one that we just saw. Deviation equals data value minus mean. So for Tamika, her deviations, again, were completed for you. Remember, her mean was 12. So the mean for Tamika was 12. For both girls, it was really 12. So 12 minus 1 would be 11. 12 minus 11 would be 1. So 1 less than the mean. So that would be the deviation from the mean. 11 points scored. 12 minus 11 again. 1 less than the mean. 12 minus 6 is 6. So 6 less than the mean. In this case, 26 minus 14, or 14 more than the mean. And then 12 minus 6, 6 less than the mean. And then lastly 12, 12 was the mean. So you go ahead and fill in Lynn's deviation from the mean now. So here you can see the answer key. So for Lynn, she had 15 points scored in one game. So that would be, the deviation would be 3 more than the mean, because again for her, the mean was 12. Okay, so her mean again was 12. So again, you would have to subtract 15 by 12 to get the mean, or to get the deviation from the mean. 12 minus 12, 12 is the mean, so 0 from the mean. 13 minus 12, 1 more than the mean. 10 minus 12, 2 less than the mean. 9 minus 12, 3 less than the mean. And 13 minus 12, 1 more than the mean. So go ahead and answer problems 3 and 4. First telling me the mean, what is the meaning of if a deviation is less than the mean, or if it's more than the mean, or if it's equivalent to the mean. Number 4, what do you notice about the deviations for each player? So for number 3, what the deviation tells you is how far away from the mean or the average a data value is. If it's a lot higher than the average, that's obviously pretty surprising. And if it's a lot lower than the average, it's pretty surprising as well. So if we take a look at 4, what do you notice about the deviations for each player? It says half of Tamika's deviations are less than the mean, and it's actually more than half. If you look here, there are 4 values that are less than the mean. Here's 1, 2, 3, 4 out of the 6 values for Tamika are less than the mean. So more than half actually are less than the mean. So in most games she scored less than 12 points. Whereas Lynn's deviation is a little bit different. They're mostly more than the mean. Only 2 of Lynn's deviations are less than the mean. So in most games she scored more than 12 points. So here, when she scored 15, that was 3 more than the mean. 13, 1 more. Okay, 1 more again, and then 12 was right at the mean. So 1, 2, 3, 4 out of the 6 games at the mean or more than the mean. Number 5 says, Carly claims the sum of the deviations for a data set will always be 0. Do you agree? Why or why not? So take some moments, take some time to look back at the data values and the deviations that you just looked at. Maybe add the sums of the deviations and determine whether or not they're 0, and explain why you agree with Carly and why you may not agree. Let's take a look a little closer at this problem. So 1 less would be like -1, -1. 6 less would be -6. 14 more would be +14. And 6 less would be again -6. 12 is the mean. So if we combine those, -1 and -1 is -2, plus a -6 is -8, plus another -6 is -14. But if you add 14, you're right back to 0. So the negatives balance out the positive. If we look at the other side, 3 more is +3. Mean is 12, so that would be 0. 1 more would be +1. 2 less would be -2. 3 less, -3. And then +1 for 1 more. So if we add those, we're at 3 plus 1 would be 4. -2 would be 2. -3 would be -1. Plus 1 would be 0. So they even out. Why is that true? Well, it's because, as we've talked before, the mean is the balance point. That means the values that are less than the mean need to balance the values greater than the mean. So it all comes back to that number line work we had been doing earlier. So it says in the next problem that some of the distances less than the mean are equivalent to the distances greater than the mean. Because the mean is the balance point, the sum of the data points on either side of the balance point are equivalent to each other. In order to get an idea of the spread of the data values, you can take the absolute value of each deviation and determine the mean of those absolute values. Okay, so there's some key terms right there. It says the absolute value of each deviation is called absolute deviation. Make sure you're marking your text. The mean absolute deviation is the average or mean of the absolute deviations. So for number 6, it says determine the absolute deviation for the points scored for each player and record your answers in the tables. Now this next part is really important, so listen closely. So absolute deviation, okay, involves taking the absolute value. When we take the absolute value of a number, that means if it's negative, it becomes a positive. If it's a positive, it stays the same. So the absolute deviation for the deviation from the mean, if it's -1, would be 1. -1, 1. -6, 6. 14 stays positive, so it's 14. Okay, so go ahead and fill out the rest right now. When you're done, unpause the video. Alright, so looking here, again, -6 would be 6, 0, 0. For Lynn, 3, absolute deviation is still 3. Right? Again, the negatives change to their positive counterpart. So the table should look like that. Problem 7 then says calculate the mean absolute deviation for the points scored by each player. So you'd have to take the absolute deviations, add them up, and then divide by the total. So add them up, divide by the total number, which would be 6. And that is where I'm going to leave you for today. What I'd like you to do is finish 7, 8, and 9, and then take a look at problem number 2 as well on the next page, and finish that. There's just a few more problems on that page. That's all for tonight. hope to have you all in class tomorrow, ready and rocking, ready to talk about some data sets.